Now, as we're looking at the worksheet from UC Davis, and we're looking back at trig intervals, a lot of people, having it been a while, tend to forget some of these rules. So we're just going to look back at some questions just to see if we can jog our memories a little bit on how to do some of these. Now, particularly when people see parentheses and powers, they start to think chain rule. So they're thinking increase the power by 1 divided by the new exponent. And that's fine if this is a polynomial. Unfortunately, this is not a polynomial because we've got our trig function here. So actually we need to do something slightly different for this one. So actually what we need to do is we need to multiply this out. So we're actually going to write it as times by itself, because that's what squared means. Then we can start doing FOIL on this. Minus 3 sine x, minus 3 sine x, minus 6 sine x, and negative 3 times negative 3 is 9. And then we can split this question up. So we've got the integral of sine squared x minus 6 times the integral of sine x, or you could put the integral of 6 sine x, plus the integral of 9, and all of these should have dx on the end as well. Now these two should be perfectly okay to work out. Sine squared x is not quite so easy to work out. Certainly not sine cubed x over 3 or cosine cubed x over 3 or anything like that. So this is one that will often catch people out. So this is where we're actually going to need to use an identity. So the identity we're going to use is this one. Cosine 2x equals cosine squared x minus sine squared x, which is on your formula sheet. Or there's different variations of this formula as well, because cosine squared is 1 minus sine squared x. Therefore, if we simplify this, we could say that cosine 2x equals 1 minus 2 sine squared x. And that's also on your formula sheet for the ACE exam. Now what we're going to do is we're going to take this and we're going to solve for sine squared x, because that's what we're trying to work out right now. This is a difficult integral to work out, but when we solve for this, we should be able to answer that question. So I'm going to bring that to this side, I'm going to bring that to this side. So I'm going to get 2 sine squared x equals 1 minus cosine 2x. And then when I divide both sides by 2, I get 1/2 minus 1/2 cosine 2x. And the advantage is now, instead of trying to answer this question, I can actually answer this question instead. So we need to know our identities when we're working on that question. So the integral for 1/2 is 1/2 x. The integral for cosine is sine, so sine 2x over 2. The integral for sine x is negative cosine x. And the integral for 9 is 9x. So when we combine terms here, 1/2x plus 9x is 9.5x. Or we could say 19 over 2x. 1/2 divided by 2 is 1/4. And our two negatives here make a positive. And as we have no limits on this question, plus c. So as you can see, we erased quite a few steps on this as we went along. So quite a long question. But I think the main thing to take from this question is they'll try doing inverse chain rule on this question, and the integral for sine squared and cosine squared are ones that you need to be very familiar with, as they ask those questions a lot.